So hello and welcome everyone to another Geometry Concepts video. We are going through the theorems in circles. And we are going to be discussing in this video the intersecting secants theorem. Just before this, I had discussed the intersecting chords theorem in a different video. And intersecting secants theorem says the same thing as the intersecting chords theorem as well. And in fact, the proof is also very similar. But oftentimes people find it very difficult to translate the proof from intersecting chords to intersecting secants. So let me help you out in figuring out how to prove this theorem. So for this theorem, we need two secants. Let's say that two secants are there which are intersecting each other at the point P somewhere outside the circle. The first secant is intersecting the circumference of the circle at points A and B respectively, and second secant is intersecting the circumference at the 2 points C and D respectively, suppose. So to prove this theorem, what I'm going to do is I'm going to join this point B and this point C, and I'm going to join this point A and this point D. Now, what I want you to do is I want you all to focus upon the triangles DAP and BCP. So what relation can be established between these two triangles? So between these two triangles, if we look at this angle P, angle BPC and angle DPA are the same angle. So they're equal. So one angle is equal between the two triangles. Also, both angles PBC and PDA, both of these are angles subtended by the same chord AC in the major arc of the circle. So according to the first angle-based theorem, this angle is also equal, which makes two angles equal in these two triangles, which means that triangle DAP and triangle BCP must be similar to each other, because if two angles are equal, of course, the third angle, angle DAP, will be equal to angle BCP. So once this is clear, once we know that these two triangles are similar, what we can do is we can write that ratio of corresponding sides are equal. So PB by PD. So this will be equal to PC by PA. So triangle BCP I'm taking on top, triangle DAP I'm taking at the bottom. So PB by PD will be equal to PC by PA, because ratio of corresponding sides of similar triangles are equal. So if we cross multiply, then we get PA into PB will be equal to PC into PD. And this is what the secant section theorem states. That the product of the sections of two intersecting secants are equal. PA into PB will be equal to PC into PD. Now, oftentimes a very common mistake that people make when they don't know the proof, especially, a very common mistake that people, and not just people, I've seen even respectable textbooks, make this mistake that when they write this theorem, they write it as PA into AB is equal to PC into CD. This is absolutely incorrect. This need not be true. This is not a theorem at all. Do not apply it as PA into AB is equal to PC into CD, because the statement of the theorem is product of the sections of two intersecting secants are equal. Sections of straight lines are always calculated from the point of intersection of straight lines. So both the sections have to be calculated from the point of their intersection P. So PA into PB will be equal to PC into PD. There is a small corollary as well to this theorem. And for that, to understand that corollary, let me make a tangent also. From this point P, let's say that I construct a tangent with a point of contact as, say, Q. Then the corollary for this intersecting secant theorem states that PA into PB will be equal to PC into PD. This will also be equal to PQ square. And you can very well use a similar kind of a proof to get to this result as well. So that's what I wanted to communicate through this video. This is the second theorem in circles that deals with lengths of straight lines. We have looked at 5 theorems in total. Sixth and last theorem in circles, again, we will look at a theorem based on lengths. Thank you.